Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at bearings. So this will involve some trigonometry as well. So a bearing is just an angle that gives us information about the direction in which something's traveling. So let's say I start here in Canberra and I want to go northeast. Well, I could go like in this direction, I could go in this direction. Both of them are northeast. Now, you might think, oh, there's not much difference between them, but let's say you're flying a plane. There's a massive difference. If you take this route, you might end up in Brisbane, and this route, you might end up in Sydney. So what we're going to do is we're going to give each of these lines a number that tells you the direction. Then there's no ambiguity. You know exactly the direction you're traveling. Do I go this path or this path? So how do we actually come up with this angle for bearings? So what we're going to do is draw like a Cartesian plane like this, and hopefully you remember the directions go north, east, south, and west. So they should have arrows on each of them. So when we come up with the angle of direction, we define it as the angle made with the north axis going clockwise. So what do I mean by that? Well, if we're going due north, straight north, we call that 0 degrees, east is at 90 degrees, south at 180 degrees, and west is 270 degrees. So let's say I was going as I was before in like this northeast direction. So we need to give that an angle. It will be this angle here made with the north axis. And we're going clockwise, which means we're going in this direction. So this would be a bearing of, let's say, 30 degrees. So what if I was going down here? So let's say this angle in here, the green angle was 15 degrees. So the way I would write the bearing, the way I would articulate this direction here, I wouldn't write southeast, I wouldn't write 15 degrees, I would write the angle made with the north axis going in a clockwise direction. I would give this black angle here. So if south, due south, is 180 degrees, this angle here is 180 minus 15. So this bearing would just be 165 degrees. And that sort of makes sense. We're going southeast, your bearing should be somewhere between 90 degrees and 180 degrees. So let's say, for example, I had a bearing that was like this. So the bearing wouldn't be 30 degrees. It's the angle made with the north axis going in a clockwise direction. It would be this angle here. So it would be 270 all the way around to west. So this would be 270 minus 30. This bearing here would be 240 degrees. And similarly, if I was going northwest, the bearing would be somewhere between 270 and 360 degrees, because 0 and 360 degrees are the same thing on our axis here. So giving it this number allows us to differentiate. Are we going, say, on a 30-degree bearing as we were going here? Or are we going on a bearing out here, which might be 40 degrees? It takes away that confusion. Okay, sorry that was a bit of a long-winded explanation. Now let's look at an example where we'll use trigonometry to help us solve a problem. So let's have a go at this question here. I traveled 12 kilometers due east, then 20 kilometers due south. And I'm going to calculate the bearing on which I must travel to return to my starting point. So just as we did for angles of elevation and depression questions, we're going to draw a diagram. It's going to have a right angle triangle somewhere, and then we're just going to use SOHCAHTOA either to find an unknown side or an unknown angle. So let's start here. Let's say this is my starting point. So 12 kilometers due east means I go 12 kilometers exactly east, and then I'm going to go 20 kilometers due south. So I'm going to end up here. Now I know that east and south are at right angles. So now I've added an extra line to make this into a right-angled triangle. So I went from here to here, and I'm now down here. I want to know the bearing from here to here. So what I need to do, I will need to find this angle. That will tell me about the bearing. So I can easily find that angle because I have a right-angled triangle and I have two known sides. So let's call this angle here theta. So we have the side opposite theta and adjacent theta. So we use tan, but of course, because we're finding an angle, we're going to use tan inverse. So theta is just going to be the tan inverse of opposite over adjacent. So make sure your calculator's in degrees mode. The answer you should get is 31 degrees. So 31 degrees is this angle here, but it's not our bearing. How do I calculate the bearing? Well, view it as I'm starting here at this point here, and then I want to end up here. So this is north. Remember, to calculate the bearing, I have to calculate the angle made with the north axis in a clockwise direction. So I know it's 270 degrees all the way to west. So it would be 270 degree bearing if starting here, I wanted to go out west. So if it's 270 out here, all I need to do is add this angle here to 270. If this angle here is 31, this angle here will be 90 minus 31, which is 59 degrees. So the actual bearing is not 31 degrees. It's 270 plus 59, which is 329 degrees. Another way you could have got that is by doing 360 minus 31. Either way, the bearing's 329. It should be between 270 and 360 because we're going in a northwest direction. So we've gone southeast. To go back to where we started, we need to go to northwest. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.